to the dawn of our new age of robots. And it's only taken, 100 years or so. Nikola Tesla was building robots in the early 1900s. And he said that by the 21st century, we will all have robots. It's not that hard. I've already built robots. The technology exists. We just need to work on it a little bit more. Were pretty much his exact words. But what he envisaged in the future with robots was robots that would free us to pursue our higher aspirations. A little while after that, he developed a weapon to end war. And in the end, he didn't release that. His reason was that it was a defensive weapon, but ultimately that was just too challenging of a concept. If you were able to build something that could kill, how could you guarantee that it would only be used defensively? So he built it, but he never told anyone the secret of how it would work. Which is kind of good, because if you build something where the only purpose is to kill, that's all it can do. Killer robots exist. We have built them, and we use them. And we have justifications for why we use them. This is a report from the US Department of Defense, only a couple of years old, looking at the ethics of robotic warfare. And the justification is that it saves lives. Fortunately, there are coalitions of campaigners against autonomous weapon systems, and there are clear channels through which we look at the issues of killer robots. The United Nations has been meeting on this recently. I'm not going to talk about killer robots. This might be a serious issue, but I want to talk about the exact opposite end of the scale. When we don't build killer robots, are we building good robots? And the reality is, most of the time, we're just building ordinary robots, and we're not considering what it takes to actually build a good robot. And that's what I want to focus on. And in fact, a little bit more about me. My background is human-robot interaction, and I'm interested not just in the individual interaction with humans and machines, but in the social, cultural, and economic rollout of new technologies. And so my day job for the last 5-6 years, I've been in Silicon Valley, and I'm running the not-for-profit industry coalition of robotics in Silicon Valley. And this is a coalition of robotics companies ranging from the very large, like NASA and Google and SRI International and Intuitive Surgical, down to the very small startups, many of which don't have names. Silicon Valley is the hotbed of robotics innovation in the world. And our Silicon Valley Robotics mission statement is to support innovation and commercialization. So what I'm deeply involved with is seeing the robotics as it's coming out of the research lab and entering the real world. And that's giving us, I believe, an opportunity to look at how do we design the best robots, and how do we ensure that it's robots that are going to be doing the best for us. Most robots, as I said, are ordinary. And we're about to see a whole wave of ordinary robots in our lives. What I want is good robots. One of the problems that we're going to face is robot smog. This is a phrase from Ilya Neubach at Carnegie Mellon University, and I think it's just spot on. When we have many robots in our ecosystem, they're going to have a multiplying effect that is as negative as smog. It's going to be annoying, irritating, and dangerous. And that's because one on its own may be fine, but many has much different impact. Has anyone been in a toy store recently? it's changed a lot in the last 20 years, and the aisles are full of talking, squawking, waving, interactive things. And they can get your attention, but how long do they hold your attention after that? And do we really want to be living in a toy store? So just a little bit about where robots really are in the world. There are very few humanoids and social robots or service robots, although this is an area that is growing. The majority of robots for the last 50 years have been the boring old industrial robot arms. But all told, there are only about 2 million industrial robot arms in the world, in total. That's not really a large number. It's growing, but industrial robot arms are big, they're expensive, and while they may be very fast and precise, they're kind of stupid. And that's the sort of robots we've been developing for the last 50 plus years. We're on a sea change in terms of the robots that we're developing now. They are small, they are cheap, they are dynamic, they're adaptable, and sometimes they're even a little bit intelligent. But the most successful ones are not terribly intelligent. So drones, very popular now. There are now millions of drones in the world, largely remote operated. Even the autonomous ones are not usually smart enough to avoid obstacles. Robot vacuum cleaners are the most widely distributed consumer robots in the world. There are well over 10 million Roombas from iRobot, and there are a half dozen other robot vacuum cleaner companies. I'd like to say that cars, most modern cars are also robots. So there are a large number of them in the world today. And the whole area of self-driving vehicles is where we're starting to, I won't quite say solve, but we're really working on some of the issues of robot smog when it comes to multiple robots interacting in a system there. And once we release robots into the wild, we're no longer in control of what happens to them. And many strange things do. When you put more robots and more people into that situation, it gets downright strange. So we do simulations. This is Duckytown at MIT, where you have 50 small autonomous systems, because to navigate around a village, it's not sufficient to know where your car is or your vehicle or where the road is. You have to know where everything else in that system is. And you have to be able to adapt to the most unpredictable things. Chris Urmson from Google has video of their Google self-driving vehicle stopping while a woman in an electric wheelchair chases a duck around the road. And as he says, there is nowhere in the DMV manual that tells a vehicle or a driver how to behave when there is a woman in an electric wheelchair and a duck on the road in front of you. But by being able to accurately perceive everything in the environment, and by being able to collect billions of bits of data about it, and we're talking about millions of hours of driving, okay? The Google self-driving vehicles have been on the road since 2009, but do you know where the most data about self-driving vehicles is currently being collected? Tesla. They announced recently that in every day, in fact about 9 hours, they collect as much data as Google have collected in their entire self-driving vehicle program. Because Tesla has so many vehicles on the road. And they're all capable of partially autonomous driving. And they're all reporting, collecting that data. But we need that much data to start to understand what a vehicle needs to do in the whole range of strange situations we're going to find happening, like ducks. In the same way, one drone is fun. But if drone delivery becomes a reality, I'm going to enjoy getting my packages on time. But if you're next door to me, you might find it very annoying. and it might start to get downright dangerous. So robot smog is a real problem. It's not just traffic management, it's also quality of interaction. This is the other thing I worry about, robot spam. And as our robots become more social, we're going to have robot junk mail. Or let's say we're going to have robots that are junk mail on steroids, because there will be so many more opportunities to be having small, comparatively valueless interactions with us in our lives. Interactions with messages that we don't care about, from people that we have no knowledge of or no real attachment to. This is already happening in a lot of our new chatbots, but more on that. We worried a lot about the negative impact that television was going to have on the 20th century. Broadcast media this is Orwell's vision of 1984 and a Big Brother society. And we worried that broadcast media was going to brainwash us, it was going to silence the voice of the individual, and it was going to enable a totalitarian state. Now, as it happened, 1984 did not turn out so bad, but advertising has become a very powerful and pervasive industry. Marshall McLuhan was much more on the money when he looked into the future. Although, ironically, some of the things Marshall McLuhan said was, I try never to predict anything that hasn't already happened, and we look at the future through a rear-view mirror. We're always marching backwards into the future, because we're seeing it through our understanding of technology and history up to a certain point. We're really incapable of truly imagining the impact of technologies in the future. Having said that, in 1962, he really described our current era and the transition from broadcast media to internet smart communication. And he said that this new form of communication, whatever it is, this kind of externalization of consciousness, it was going to enable the world's information to be immediately searchable. It was going to allow us to connect as if we were in a global village, individual to individual. And it was going to allow us to have individually customizable information that would be in a saleable form. So effectively, he predicted Amazon, eBay, Facebook, and Google. But I see us now at the dawn of the next era. And that's the era of the artificial intelligence, the artificial personality, the conversational agent, the chatbot. And the chatbot is the building block of social robot interactions. These days we have them on our phones. And where McLuhan talked about our communication technologies as enabling the exchange of information and personal relationships, our new technologies are transactional, and they're enabling the exchange of interaction and of artificial personalities. And I see that as a significant change. Also, while they may be successful in small niche areas, by and large, pseudo-human interactions are very unsuccessful in a general basis. Nest has been successful, and there is this tension between creating these general platforms, where I believe Amazon Echo is going, and yet it's very successful only with answering narrow task things like Alexa, play music. Google Home is going into the same market, and they're consciously targeting certain interactions rather than trying to be a broad solution. But this is the tip of the wave. Already on the market are a multiplicity of embodied conversational agents. And many of these will be failures. I don't know yet which ones will be successful. And none of us really know how this is going to play out. But these are on the market, if not today or already, then by the end of this year. Which puts us rather much at the peak of inflated expectations. If you're familiar with the Gartner hype cycle, this worries me. I want you to not be too disappointed with the robots that you're going to see in the next decade, because they're not that sophisticated, and yet they're going to be having social interactions with us. This is where I encourage better design, to be focusing on making better interactions, better relationships. And the reason is because we are certainly going to need robots. At the end of this trough of disillusionment, there will be the slope of enlightenment and the plateau of productivity. I want us to get there with a smoother... I want to smooth out the bumps in this pathway. One of the things that we need to look at is smoothing out the bumps in this pathway. And you've probably all heard of the concept, the Uncanny Valley, which springs from Freud's concept of the uncanny, or unheimlich, which is at the basis of almost every horror story, where a corpse is just fundamentally different to us than a living person. It's uncanny. It's almost like a living person, but it is deeply unsettling to us that it is different in a small way. So we like technologies as they become more human-like, more lifelike, and then all of a sudden we really don't like them when they cross a certain point. And this is exaggerated when movement is involved. So we find it both easier to believe that something is alive when it moves, and also more unsettling when it moves badly and is almost human. The work of Hiroshi Ishiguro is always right on the cusp. In fact, the term the Uncanny Valley is from Masahiro Mori. Japan has been doing some of the most advanced research into humanoid robots, and this has been carried on by Hiroshi Ishiguro, who creates the most human-like robots, I think, of anybody. And they look very convincing here when you're seeing them flat in 2D. When you see them in 3D, it's a little bit less convincing, and there are certain things in the posture and positioning and skin texture and color that just jar. But when you see them moving, there's really no doubt that it's not real. And this is exacerbated when you look at the content of a conversation or an interaction that we have. So we're very bad at building replica humans as we layer more layers on. But we're actually very good at persuading ourselves that something is human if we go back to simple. Now, following on from the Uncanny Valley, this idea of incongruence or cognitive dissonance, has anybody done the Stroop test? Okay, the challenge here is if you read it yellow, blue, orange, you read it far more quickly than if you read the colors, which are green, red, blue. And I've been practicing that, and I can still not do it quickly. And it's the difference in processing speeds between these two different ways that we are looking at the information, and that's learned. So I believe that there are elements of the Uncanny Valley that are instinctual, but there is a lot that's learned response, as we see in forms of the Stroop test, which has, to me, a lot of positive implications as we build more sophisticated robot mechanical systems. And we need to do this to develop effectively a new ontological category that is machine. It is neither dead nor alive. It is neither fully object nor human or fully agent. for the next, I don't know how long. I mean, we've been evolving human society for millennia. It's going to take us a long time to work out what it's like with added machines, but we are involving machines in our lives rather rapidly at the moment. So I believe this is the best principle we can have. Don't try and build humanoids. Focus on building robots and making it clear that we're building an artificial construct. It is a robot. And starting to learn to live with that. Yet we love our humanoids. I mean, they're such a major part of our literature. From the time of the Greeks through to Rossum's Universal Robots, which first coined the phrase robot. Although in this instance, what we did with our robots is we created a slave class, which then rose up, overthrew us, and killed us all. Was the problem the robots, or was the problem that we created a slave class? In Metropolis, we explored the theme of the slave class again, but we went a little bit further and we created a robot that was able to be an exact doppelganger for a human and cause this conflict of identification. And that existential angst, that conflict of identity, underpins so much of our storytelling about humanoid robots. And that leads to really bad robots. So we've had killer robots. Humanoids fall into the really bad robot category, at least for a long time to come. And we've seen this with films like Blade Runner and Ex Machina. They may be really bad robots, but if we are able to build something so sophisticated that it develops agency of its own, and we are very far off this, does it really matter whether it's human or not? That's the essence of the Turing test. Alan Turing, the father of the computer, developed the Turing test to understand how to identify artificial intelligence. When we'd succeed in creating artificial intelligence, his idea was that we would be unable to tell it apart from human intelligence. But like I said, that is a long way away. In the meantime, our state of art in humanoids was recently in the DARPA Robotics Challenge. So just to backtrack a little bit, the DARPA Robotics Challenge is one of a series of challenges DARPA sets. And the reason they set these challenges is they say, what is that moonshot? What is 20, 30, 40 years out? What do we believe we can accelerate and bring closer? Can we get this technology to within 10 or 15 years out so that it starts to become commercially investable? And the last DARPA challenge was self-driving vehicles. In 2004, no car completed the course. It was a 7-mile course in the desert, and not a single team was able to succeed. They ran the test again 1 year later, and almost all the teams were able to complete the course. They ran it in a simulated urban environment in 2007. Almost all the teams completed the course. And then Google bought them, and in 2009 you had self-driving vehicles on the streets of Silicon Valley. And Elon Musk predicts that self-driving vehicles are almost here and definitely within 2 years' time. So on that time frame, DARPA took a technology that was 20 plus years out in 2004 and has definitely accelerated it into commercial territory. Now, humanoids, I think it's still further out, simply because these are very expensive. To be able to do a job well, they are expensive, they are, comparatively speaking, fragile, and most tellingly, the commercial applications are very small. Whereas for self-driving vehicles, it's something that we can all potentially have or use. I don't know if we'll own them, but we'll use them. But the use case for the humanoid robots in the challenge was for disaster relief scenarios. So it's still looking at building a very expensive robot solution for something that will not have a very wide application. But it will be very important when it is used. So the incentive for this challenge was the Fukushima nuclear disaster, where if someone had been able to go into the reactor in the first 12 hours and shut it down, the meltdown would have been prevented. And it was just not possible to send in people, and we had no machines that were capable of going into that environment. So this challenge is very explicitly saying, what things do we need to do that? And when we say humanoid, the Atlas robot that you just saw, it was the most humanoid in many ways of them. A humanoid robot needed to work in a human environment, using human tools, driving human vehicles, going through doorways, using tools. Many of the teams took rather creative approaches to what that was, and in fact the teams that did best, Team Keist and CMU's Team Chimp, they used tracks and wheels. So the top corner, Team Keist, has wheels on its knees and feet, and it drops down and collapses into kind of a tank, so it's very stable when it moves. And Robo-Simian, that's right below that, has 4 limbs that kind of defy an orientation. It doesn't have legs down, head up as its modus of operandi. It does the most amazing kind of yoga moves, and it utilizes things that a robot can do better than a person can do. Now, I thought this challenge was amazing, and in the space of just a few short years, robots went from being unable to achieve any of these tasks to most teams being able to achieve these tasks in a 1-hour time frame with limited, degraded communications, using power that they were carrying in themselves, so they were not tethered, and there was no backup if they fell over or if anything went wrong. And the tasks involved driving a vehicle, opening a door, turning a tap, drilling a hole in the wall, doing a mystery task that could have been turning a switch on and off or something similar, climbing over rubble or moving rubble out of the way and then climbing upstairs. Now, this was state-of-the-art in achievements, but you know the biggest achievement that came out of the DARPA Robotics Challenge was the public relations victory. Because it started off with everybody talking about Terminator, and it finished off with this being the most popular video of the DARPA Robotics Challenge, with millions of views. And it gives us a much better sense for the real state of art of humanoid robots. Now, do go and see the actual success. But I think, as Rodney Brooks quipped during the competition, we don't need to worry about the robopocalypse, we just need to close the door. And this wasn't necessarily an unforeseen effect. So this is something the director of this challenge talked about a lot at the start, was managing public expectations of robotics and allowing us to see how sophisticated or not the technologies really were. So he was encouraging everybody to consider robots as something like a 1-year-old child in terms of ability, physically and mentally. And we see this principle in Star Wars, that beacon of robot design. Human is not necessarily best, or humanoid. The best robots are the simpler robots. And we only really need robots in the world that are just sophisticated enough to do the things that they can do. If they look more sophisticated, we expect more from them, and we will be very disappointed when we don't get it. The principle is called design downwards. And there's nothing wrong in taking off all those extra features that we don't need on robots. Why? because all we need to do is put 2 dots on a cookie and we've got a face. Okay, Reeves and Nass showed in their work on the media equation, looking at humans' relations to computers, that we attributed agency, intelligence, and all sorts of human characteristics to any sort of object if it had a couple of simple behaviors. This test in psychological test, 1944, the Hyder-Simmel test, shows the simplest shapes that you can have. There's no additional sound, but at the end of this clip, you will all be able to tell a story about what's happening here. And you will have given personality to every single thing that's happening there, every shape. We might not all agree on the story and the personality, but it is 100% that we have all given personality to these. I have to let you know how the story finishes now, don't I? Happy ending. Although someone's a bit angry about it, not happy for everybody. So illustrators and animators have known this for a very long time. It takes very little for us to attribute intelligence and agency to objects. How do we utilize that to design good robots? We've been working on the building blocks of good robot design for a long time. We don't always incorporate them, though. Some of the companies that are coming out of Silicon Valley that I really like are building robots that you're going to see in your daily lives, in hotels, in shops, in places like that. And they are using a lot of these features of good design. So Relay from Savioke, I should have explained, some of the features are, when you build a robot, building a circular robot is a really good idea because not only is it more efficient when it's turning, you're introducing far fewer points at which you can pinch or trap somebody. Use coloured lights to show when a robot is active and give some idea of its intent for which direction it's moving. What I really like about Relay is that it doesn't use voice. It has a screen where it uses words, and the other communications happen separately. You get phoned when the robot's at your door. The robot itself makes little R2-D2-like chirpy noises. And that's managing people's expectations. People pat it on the head when it makes a delivery, instead of trying to engage it in conversation. So you have a far more successful interaction, and yet it's quite clear what the robot is doing. Ditto Tally, which is going to be doing stock taking in shops. It has the same physical principles of good design. You have the largest part of the robot low down near the feet because it's going to do the least harm to the robot, to the shelves, or to the feet of the person than if you have protuberances higher up. It has eyes so that people are telegraphed what the robot is doing, where its intent is. And that's just following basic human behavior. As you walk down an aisle, or a corridor, you scan ahead of you, and if you see something coming towards you, you look at its eyes to see whether it's looking at you or looking in another direction. And you base your idea of what it's going to do and its movement off things like that. So incorporate those features of faces into robots. One of the other things people have done with robots is they've incorporated, often they've built in noise that they didn't need to have. Our engines, our motors are getting very good and soundless, but we expect to hear something moving if it's moving near us. And there are certain pitches at which you can design the noise in that have different emotional impacts on us. So there's been I think this is one of the companies that worked at the high noise, viz the low noise, viz the noise that made people feel kind of comfortable about, oh yeah, I hear the robot, I know what it's doing. They also follow people. And in this instance, fetch and freight work in warehouses, so it's a more constrained situation than working in a hotel. You have limited people. So it doesn't need to understand every person in the environment. It doesn't even need to understand you as a person. To operate as a follow-me robot, it only needs to follow your feet. So that's where the focus of this robot interaction is, working out where the feet are and how to stay the right distance away from the feet. When we do robots well, they're invisible to us. Ordinary robots become appliances really quickly. And that, to me, is the essence of good design. But we're not just building robots. We're not interested in this just because we want boring appliances or because we want cool, geeky robot toys. Now, if you listen to the talk this morning, I think Daniel Cohen talked about anybody who says what's coming in the future is either an imposter or a prophet. I'm going to talk about what's coming in the future, but I don't look at it in terms of saying, we have these new robots, therefore they are going to change the world in these ways. I look at it completely opposite. I say the world has these problems, and these are the problems that are most likely that we can solve with robot technology. This is where we have the strongest need to build robots. So I'm not predicting what robots are going to do, but I am saying this is where we need to be applying robot technology. And perhaps that will be what shapes the robots that come in the next 50 years. We're going to have 10 billion people in the world. We have 7.5 now. The incredibly rapid expansion of population in the world is already challenging us to the nth degree. 75% of the world will live in cities by 2050. Urbanization is taking up arable land, and it's creating an entirely new way of living. Our average age is increasing. Our retirement, our workforce is getting much closer to retirement, and we will have more older people than we have young people. And for all of that, we need to double food production. We need to double food production because we do not have extra land to grow food on. So we need to use the land that we have better. So I like to focus on the future areas for robotics. Elder care is a clear need, but I see that as still being a little bit difficult and far off. But the whole interconnected network of manufacturing and food production, our physical goods supply chain, particularly those physical goods that are critical for our survival, our food production, these are the areas that are the best use of robotics technology. And we're already building a lot of robots that are capable of going into these fields. This is a new robot farm in Japan, one of several initiatives. And I think it's exciting to start to look at how we can reuse urban space for the production of food. We use robots for grafting, transplanting, and other genetic technologies. We use robots for pruning. This is a French robot for vineyards. We use them for inspection. We use them for transplanting. We use them for weeding and fertilizing and sensing. We use them for thinning and planting. They potentially have a huge impact when we start to use many small robots on the farm, because the large machinery machinery on farms has gotten bigger and bigger and bigger, and that has a huge impact on the productivity of the soil. It compacts the earth, it minimizes how much you can actually use because you have to use a lot of roadway space. So if we have a lot of small robots, we actually, in every farm, free up more space. But we also create precision agriculture in a way that really hasn't existed before, where we can start to treat each plant individually. And that means that we don't waste all of the inputs into a farm where we overwater some areas just so that we don't underwater others, where we over-fertilize and over-pesticide everything just because we can't afford not to treat some parts of it. And we start to see multi-robot systems, and not just in plant agriculture, but moving into animal care and management. And you think, wow, robots and animals, that doesn't sound good. But it's one of the most well-established areas of robot business, is milking machines. And it goes well beyond milking machines. It's actually whole dairy management systems, to the point that some dairy farms are people-free. The cows decide themselves when they want to milk. They go into the milking machines. They move into food areas. There are robots pushing food towards them. There are automated back scratchers. Okay? There's automatic gate controls so that the cow that has given a lot of milk and clearly needs to have a lot of good food because they're in high productive mode, goes down to the rich pasture areas. Whereas the cow that is kind of off form might get earmarked for treatment, or might get sent to a less rich pasture area. So you can start to get very responsive cow management. And from everything I see, the stress hormones in cows have reduced. And this creates happy cows. It also creates happy farmers that can deal with labor shortages and not having to get up at 3 in the morning necessarily. And we need to do more to keep farmers on the land. And just very quickly, so for me, the future is robots, but it's not humanoid robots. Sorry. It's robots that are functional and that are simple, that we have a really clear need for. But at the same time, we will see more robots in our lives, and they will be having social interactions with us. So we need to design robots for good interactions. There are principles for this, and this represents a lot of good thought from multiple disciplines. But we still have trouble taking these good principles and putting them in early into actually building robots. So in conclusion, if we end up with robots behaving badly, we have only ourselves to blame. Thank you.